All right, my friends, for part A here, let's show the steps necessary to convert this into this rectangular form. So we'll have r equals 3 over 1 plus 2, and sooner or later you replace cosine with x over r. From there, we could multiply both sides by the denominator to clear the fraction out. And then let's distribute r in. From here, you could add the 2x over, square both sides, you get r squared can be replaced with x squared plus y squared. On the right side, we get 4x squared plus, what would that be, 12x, I think, plus 9. All right, from there, we could, it looks like they subtracted everything over and got 0, so let's subtract the x squared over, and then subtract the y squared over. And we'd end up with 0 equaling 3x squared plus 12x minus y squared plus 9, which does match what they asked us to find. There we go. Okay. Points. Swapping cosine x for x over r. 1 point, even if you didn't do it in the first step somewhere. Let's see. Next, squaring 2x plus 3 correctly and getting this expression. 1 point. Let's see, what else? Oh, replacing r squared with x squared plus y squared. 1 point. And then for the whole step-by-step solution leading to the correct answer, 2 points. As long as you don't have any miracles that occurred. There we go. Okay, as long as you showed very clearly you do know what you're doing. Okay, for part B, graph the function on the rectangular coordinate plane. So we've got 3x squared. Actually, let's just start completing this square. So up here, I would factor the 3 out. And then complete the square, so you'd need a 4 here. Careful, you actually just added 12. Factor that. And then we can just divide both sides by 3. So you could write x minus 2 squared over 1 or 1 squared, or just x minus 2 squared. I prefer to think of 3 as square root 3 squared, considering what I'm going to have to do next. And then on the right side, I have 1. So let's see. So let's graph it. It's a hyperbola that got shifted to the right 2, it looks like. And then from there, let's see, yeah, to the right 2. Did I do the other one wrong? Yeah. Okay. Sorry. Anyway, let's see. From there plus to the right and left 1, and then up and down. Square root 3. Square root 3 is about 1.7. After our trig unit, that's something we should know. If you didn't, then hurry and put that in your back pocket. Boundary box, asymptotes. All right, x is positive, so it's going to open horizontally. Make sure that your hyperbola is tangent to your boundary box and that it demonstrates asymptotic behavior. Meaning that, like, it basically starts thinking it's these line graphs as it goes out on the right. So let's see, points. All right, so having a hyperbola that opens horizontally, that's worth 1 point. All right, having the center at 2, 0 is worth 1 point. Having the boundary box be 2 units wide and 2 square root 3 units tall, so having a 2 by 2 square root 3 boundary box, 1 point. Having the vertices be at 1, 0, and 3, 0. One point. And then the last point is for the asymptotic behavior on all four corners of your graph. So 1/4 of a point for each, basically your graph getting closer and closer to it, not like deviating away from it. So we'll call that asymptotic behavior. 1 point. And that's your 5 points there. All right, my friends. Part C, find the foci, add the coordinates of the foci to your graph for part B. Show clear work that supports your answer here. Okay, so let's look at that. So Pythagorean identity, c squared equals a squared plus b squared for hyperbolas. We're finding c. A and b are 1 and square root 3, so we get 1 plus 3 after we square them. So c squared is 4, which means c is plus or minus 2. Now, if you just had c equals positive 2, that's actually fine, because the way we've been interpreting c as the distance from the center to your foci, that actually kind of makes sense to just say positive 2. So now let's turn that into information here. So we'd have one focus at the point 4, 0. And then we'd have another focus at the point 0, 0. Okay. So points, 2 points for finding your C values with work along the way. 1 point for getting a focus at 4, 0, and 1 point for getting a focus at 0, 0. All right, writing the equations of the asymptotes, I really do hope you just use point slope. So both lines go through the center, and so they both hit the point 2, 0. And the slopes, this line that goes up to the right has a slope of up root 3 over 1, so that would be a slope of root 3. The one that goes down has a slope of down root 3 over 1, so the slopes would be plus or minus root 3. So if you use point slope on it, you just do y minus 0 or y, either way, same. And then the slopes would be plus or minus root 3, and then times x minus 2. Again, if you just said y for y minus 0, that is perfectly fine. There you go. So 1 point for getting the slopes right, plus or minus root 3, and then 1 point for getting the rest of the information right there. Now, if you decided to write your answer in y equals mx plus b form, you'd have a little bit more work to do. I'm not saying that I wish you had. I'm actually kind of wish you didn't bother. But you'd need to separately break this into 2 equations. One with positive root 3 as a slope, and one with negative root 3 as a slope. And then you distribute and go from there. So one answer, if you went y equals mx plus b, would be root 3x minus 2 root 3. And the other one would be y equals the opposite of root 3x plus 2 root 3, just from distributing that in. So if you wrote both of these answers, then that would be equivalent to what you did up here with point slope. Just a little more work.